Alright, today we're going to be talking about partial derivatives. So what does that mean? Say we have some function that takes x and y as an input, for example x squared plus y squared, and we want to know how much it changes when x changes, but not necessarily anything about y. We can take the partial derivative with respect to x, and that'll tell us how much the function changes when we change x. So the important thing here is when we're taking the partial derivative with respect to x, you can write it as like f with a subscript of x, or you can write it as partial f. This is different than the regular derivative sign. You have partial f over partial x. All we want to do, take the derivative of x just like you would any other time, but any y's are just a constant. So instead of thinking we have y squared here, just think of it like any other number. So we all know how to take the derivative of x squared. We're going to drop the 2, leaves us with 2x, and then y squared is just a constant. And if you take the derivative of a constant, you just get 0. So for this function, the partial derivative with respect to x is 2x. If we wanted to take the partial derivative with respect to y, what that would look like is that x is a constant. So if we take the derivative of x squared, which is a constant in this case, we're going to get 0. And then we're going to get the derivative of y squared, which is 2y. Another slightly trickier example, say we have some function that takes x and y. That's x squared times y squared. We're going to think about this the exact same as if we had a function like 3 times x squared, because 3 is just a constant. So if we take the partial derivative with respect to x, we take the derivative of x just like we normally would, 2x, and y squared stays the same because it's a constant. It's the same as if you had x squared times 2. Y is a constant, 2 is a constant. When we take the derivative, we drop the 2 down, and we're left with 4x. In this case, we drop the 2, and we're left with 2x times x squared. Now, if we wanted to take the partial derivative with respect to y, it's the same thing. X squared is a constant this time, so when we take the derivative of y squared, we just get 2x squared y. There you go. That's how you take the partial derivative of a function.